and the presentation will take place. So I'm starting to discuss the Samuelson's multiplier accelerator interaction model. Last day, I defined what is the meaning of acceleration principle here in the Samuelson's model. What is the meaning of acceleration principle? We have to increase the consumption expenditure, and that consumption expenditure will in turn increase the investment or capital stock in the economy. This we call the induced investment. And if consumption expenditure increases by say 1%, then the acceleration principle states that a magnified change, maybe 15% increase in stock. So compared to increase in consumption expenditure, it will be, the increase in investment will be quite a lot. So magnified change. Similarly, I mentioned what is the meaning of multiplier. At aggregate level or macro level, there will be some fiscal stimuli, and that fiscal stimuli may come in terms of improvement in consumption expenditure, investment capacity, or net government expenditure, increase in government expenditure. Okay. And if these increases by say 1%, again, the economy will, entire economy will increase by say 12%. So this kind of thing, multiplier effect. And when you will learn your macroeconomics, the ideas will be more clear to all of you. So any question regarding the basic concept of acceleration principle and multiplier? So maybe today you are not ready for the Matheco classes. So please check all these things. Whatever difficulty you face, you should ask me in the next class. So keeping in our mind the idea of acceleration principle as well as the notion of multiplier, I'm stating the national income identity. The national income identity is presented as YT is equal to CT plus IT plus G naught. So income in period T is equal to consumption expenditure in Tth period, investment expenditure in Tth period, plus government expenditure. Now here we assume G as exogenous. Okay, it is given to the economy. It is pre-decided, it is given. So while C, I, Y, this will be determined from the system, endogenously determined, G naught is exogenously given here. Therefore, I'm using the term G naught, not GT. So suppose the equilibrium condition of the national income is given by YT is equal to CT plus IT plus G naught. C, I, and G are all planned quantities. And as I mentioned, we assume G as exogenous, that is, it is given from outside. Okay, it is a given, it is a constant amount in this model. Next. How we are defining consumption here? Consumption responds to income by one period lag, and it is proportional to YT minus 1. So last day, you told me consumption, is a function of income. So here also we are considering the same thing. Consumption is a function of income. However, I'm considering a lagged response, At individual level, when we think about the consumption expenditure, it happens that at the beginning of the month, we are getting the salary, and on the basis of salary of March, I'm planning my consumption in the month of April. Then again, on the basis of salary of April, I'll consider or I'll plan my consumption in May. So at individual level, this happens on regular basis. On the basis of the salary which we earn in the previous month, we plan the expenditure in the next period accordingly. At national level or at macro level, also this happens. On the basis of the aggregate income, on the basis of the total production, this Y is also equivalent to total output in the economy. On the basis of the total output, there will be some planning regarding the consumption expenditure. So both at micro level as well as macro level, it's very consistent to assume consumption in Tth period is a function of income of T minus 1th period. Okay, so Samuelson framed consumption in this way, and he assumed Ct is proportionally related to Yt minus 1. Proportionally related to Yt minus 1. So it is not a linear function of Yt minus 1. Rather, it is proportionally related to Yt minus 1. So this is equation number 2. Assuming full capacity utilization at each period, any increase in demand for consumer goods would require addition to capital stock to meet the rise in consumer demand. Okay. In Samuelson's framework, Samuelson considered whatever capital I have, that will be totally spent in a particular period to produce the consumption commodities and investment goods. Okay, so entire stock of capital will be cleared at each market. So if there is any addition to the consumption expenditure, any improvement or any increase in consumption expenditure, economy needs additional capital stock to meet that rise in consumer demand. So in equation 3, we have assumed that each 1 rupee increase in consumer demand requires alpha rupees worth of capital goods, and this incremental capital output ratio is the same irrespective of the stock of capital. Okay, so too many things I mentioned. So let's consider equation number 3. We are considering investment in Tth period is exactly equal to alpha into consumption in Tth period minus consumption in T minus 1th period. Okay, so we are considering incremental consumption. Generally, consumption increases. It's a rising function. It's a rising function of income. It may be steep, it may be mildly, slowly increasing. However, it's a rising function of income. Okay, so it is expected that Ct will be greater than Ct minus 1 because of increase in population, because of increase in income, because of change in the entire economy, because of inflation. There are so many things. So it is expected that consumption in Tth period will be greater than that of T minus 1th period. Now, in Samuelson's model, the entire capital which was there in T minus 1th period, that was fully used, fully employed to meet the consumption demand of the previous period. Okay, so if there is any increase in consumption in Tth period, that will be phased, creating an excess capacity. So we have to improve the stock. We need some additional investment. Economy needs some additional investment if there is an increase in consumption expenditure between two periods. So entire capital of T minus 1th period has been used, fully utilized to produce or to meet the consumption demand of T minus 1th period. So if there is any additional or excess demand, excess consumption expenditure, which is marked by CT minus CT minus 1, that will be faced by new investment. Okay. Now here I am mentioning that any increase in demand for consumer goods would require addition to capital stock to meet the rise in consumer demand, number one. Number two, each 1 rupee increase in consumer demand requires alpha rupees worth of capital goods. Okay. So if consumption increases by 1 unit, we need alpha rupees worth of capital goods to meet that 1 unit increase in consumption demand. And this incremental capital output ratio, so this alpha is called the capital output ratio. Incremental capital output ratio is the same irrespective of the stock of capital, which means if I consider, CT minus 1 minus CT minus, consider CT plus 1 minus CT, whatever be the period, this particular capital output ratio will remain alpha. So if there is any incremental consumption expenditure, this incremental capital output ratio will remain constant. It will not differ between T minus 1, T plus 1 T plus 2, T plus 1. This value will not change. This is a constant. Alpha is a constant. Any question regarding equation number 2 and equation number 3?
Ma'am, is there any restriction on alpha? Means, can it take any value?
I'm coming to all these things, whether alpha will be greater than 0, less than 1. Okay, so all these things I'll discuss. Now to begin with, just check whether you are getting the equations like this.
Ma'am, alpha is the capital.
Just a moment. Since the question is coming, at this time point, I'll tell you both beta and alpha are positive. Okay, both alpha and beta are positive. Yeah, there was another question. Yes, please.
Ma'am, alpha is the incremental capital output ratio irrespective of, what is the term?
Irrespective of the stock of capital. Irrespective of the stock of capital, Irrespective of whatever period you consider, whatever stock you consider, this incremental capital output ratio remains unchanged. If there is a difference in consumption of past period and present period, investment will rise, because here we are considering the change in capital which is coming from the channel of change in consumption expenditure. Okay, so, and if there is a gap between the two, investment will be magnified, as we learned by acceleration principle. Now, what is the value by which it will be magnified? This value is alpha, which we call the capital output ratio, and this alpha remains constant across the periods. Okay. If you think about reality, in fact, capital output ratio also changes. However, to frame the basic model, we are considering this alpha is a constant. Got the point?
Yes, ma'am. Thank you.
Now we will substitute. Our objective is to find out the time path of yt. So everything we will like to present in terms of yt, okay, y variable. Because as I mentioned last day, we will like to present the time path of income, time path of national income, time path of national output. Okay, so for that matter, we will substitute equation 2 and 3 in equation number 1. So equation number 1 was yt is equal to ct plus it plus g naught. In place of ct, we are putting equation number 2, that is beta yt minus 1. And in place of it, we are putting alpha ct minus 1 plus g naught. So I'll tell everyone to write this equation, because at the next step, you have to replace ct minus 1 in terms of y variable. Okay, so please write down this format. Yt is equal to beta yt minus 1 plus alpha ct minus 1 plus g naught. Now, from equation number 2, we got ct is equal to beta yt minus 1. So in equation 4, we have ct minus 1, 2. Okay, apart from ct, we have ct minus 1. So ct minus 1 is equal to beta yt minus 2. So the multiplier also, that, you know, the concept of multiplier also, that is also not changing across the time. So the incremental capital output ratio alpha and the multiplier beta, that remains unchanged. In fact, these two values work for all the periods. So substituting for the multiplier, actually the value lies between 0 and 1. Alpha we will consider positive. So all these things will come in our due context. However, to begin with, we are presenting the model only. So substituting these equations in equation number 4, here I missed one plus g naught. Please add that thing. Yt is equal to beta yt minus 1, that is the ct part. Then in place of alpha into ct minus 1, I am putting these values, beta into yt minus 1 minus yt minus 2 plus g naught. So if anyone has any question, any problem regarding this step, please ask. Then I am keeping yt as it is. Yt minus 1 I am taking common. Beta is also common between these two factors. So this can be written as beta into 1 plus alpha yt minus 1 minus alpha beta yt minus 2 plus g naught. Is equation number 5 all right to all of you?
Yes, ma'am.
Okay.
Ma'am, can you please explain
This part, how I substituted or how I took common? Which part, please?
substitution part?
Ct equal to beta yt minus 1, you are understanding? This is the basic framework, this model we have considered. Beta is the MPC. If you consider dct by dyt minus 1, this value is beta. This is also the multiplier in our concept. So if ct is equal to beta yt minus 1, ct minus 1 should be beta yt minus 2. Is this thing clear to you?
Yes, ma'am.
So in place of ct, I have written beta yt minus 1, and in place of ct minus 1, I have written beta yt minus 2. Is it okay?
Yes, ma'am.
Then I am taking yt minus 1 common. Now yt minus 1 is there with the first term and yt minus 1 is there with the second term, alpha beta yt minus 1. So if you take yt minus 1, also beta is common between these two terms. So beta into 1 plus alpha into yt minus 1. Is it clear? If you find yt minus 1 common, you are getting this term. Is it okay?
Oh, it's okay. Thank you very much.
Okay. So rest of the things are there. Minus alpha beta yt minus 2 plus g naught. Rest of the things are there. This is equation number 5. Now, if you look at this equation, one order has increased in our micro-based market system, be it the cobweb structure, be it the inventory adjustment model. We had two layers, PT and PT minus 1. Here we have three layers, three periods simultaneously, T minus 1 and T minus 2. So three periods are there. So this is a second order difference equation in YT with two parameters alpha and beta and one exogenous variable G naught. Is this line clear to all of you?
Yes, ma'am.
This is a second order difference equation. Second order difference equation. Because we have yt minus 2, t minus 1, t. Okay. Next, we are moving towards the time path of yt, towards the derivation of time path of yt. So, there will be two parts, complementary function and particular integral. So first, we are trying to find out what will be the particular integral here. To get this idea, basically we derive the equilibrium value of the variable. Here the concerned variable is y, so we need to find out the equilibrium value of y. So for an equilibrium solution, in fact, this is the intertemporal equilibrium solution, you know. So for an intertemporal equilibrium solution, we set yt minus 2 is equal to yt minus 1 is equal to yt is equal to ye. So this is the requirement. Whatever be the time, the notion of equilibrium remains unchanged. So for all the periods, the equilibrium value of income is given by ye. So once you understand the notion of intertemporal equilibrium, plug this value in equation number 5. And please check whether you are getting the value of ye to be G naught by 1 minus beta.
Yes, ma'am.
Rest of the students?
Yes, ma'am.
So call it equation
Yes, ma'am.
ye value is G naught by 1 minus beta. Okay, so here please mark where beta is greater than 0 less than 1. Multiplier is greater than 0 less than 1. And G naught, as you know, that is given from outside. So at equilibrium, income remains stationary. Equilibrium income is independent of accelerator. As income remains stationary, accelerator basically ceases to operate at equilibrium. So if income remains stationary, consumption will also remain stationary. So there will be no change between two-period consumption. So there is no need of additional investment. Therefore, accelerator ceases to operate when income remains stationary. Accelerator ceases to operate when income remains stationary. Now I'm moving back to equation, coming up to this position, I'm moving back to equation number 2. So from equation number 2, we can frame an idea So what is the minimum possible value of beta? Anyone?
0.
0. Yes, 0. Because it may happen that income is changing, however, your consumption is not changing. It is possible. There will be no change in the consumption in Tth period. It will be similar to that of the previous period consumption. So minimum possible value is 0. And what is the maximum possible value?
1.
1.
Whatever increase in income you are facing, the entire increase you may spend in consumption, incremental consumption. Okay. So logically then,
Ma'am, how you have used differentiation here?
just a minute. Here we are considering the discrete time period, and for that matter, while I am giving you the basic model, I am not using calculus. Okay, and therefore I told you I'll come back later to these concepts and I'll give you the idea about the entire thing. Okay, so typically it will be better to use the notion, okay, and here this kind of concept maybe. Okay, however, to understand the matter, in general, time is continuous, and while you will do your macro, you learn beta as the marginal propensity to consume. So in general, this idea is with you. You have the idea that, this beta is nothing but change in consumption due to change in income. Am I right? You have the notion of marginal propensity to consume?
Yes, ma'am.
Yes.
Okay. So therefore, as a note or to clarify the ideas, I am telling you this beta is nothing but change in consumption due to change in income. Though I am considering time to be discrete, that is not changing the basic ideas of macro modeling. Okay. So beta can be considered as a factor when we are using the term multiplier. Beta can be considered as a factor, change in consumption due to change in income. Okay, so actually, just a minute. When I defined the multiplier, you will find that I used, the term 1 minus 1 minus NPC. The multiplier will be generated using the calculus, etc. So the basic idea underlying macro modeling is not changing here. Therefore, while I am explaining the matter, I am trying to tell you this beta is nothing but marginal propensity to consume, and this multiplier is nothing but 1 by this idea. Okay, so that you can understand what is the idea of beta. what can be the range of beta? Okay, so this I'm putting as a side note so that you understand this beta is not totally unrelated factor. This beta is basically MPC, and this MPC will determine basically the notion of multiplier here. Now, if beta is MPC, this is dCt by dyt minus 1. So, underlying macro modeling is guiding us that the beta value should lie in between 0 and 1. So, that side note I want to mention here. Is this clear to all of you?
Yes, ma'am.
While you are writing the Samuelson's model, you don't need to explain all these matters, you know. Only you need to understand beta will lie in between 0 and 1. That's all. Because at the equilibrium level, you are getting the value to be 1 minus beta. Okay. So if I follow the strict inequality, YE is a positive amount. That I want to mention. You know, G0 is a given positive constant because this is a government expenditure. If we follow the strict inequality, generally for MPC, we follow the strict inequality, though theoretically the minimum possible value is 0 and the maximum possible value is 1. Generally, 100% of income will not be consumed, so the value will be not exactly equal to 1, and over the period, consumption is an increasing function of income. So it happens that since it is a rising function, you know, so between the two periods, there will be at least a minimum change in consumption. So we follow the strict inequality for beta. It lies in between 0 and 1. And for that matter, this YE is a positive amount. This income is a positive amount. G0 by 1 minus beta is a positive amount. Beta is a positive fraction. So G0 by 1 minus beta is a positive amount. Okay. So here, please add, since beta lies in between 0 and 1, in general, YE is greater than 0. Actually, here you are adding YE is greater than 0. And you know, from your idea of difference equation, first order difference equation, this YE is the particular integral too. This YE value is nothing but a particular integral. So your PI is equal to G0 by 1 minus beta. Is this clear to all of you? Yes, there is some question, yes?
I was asking, can you please explain once why consumption responds to income by 1 period lag? Why there is a lag
Of the Samuelson's model, and this is a quite natural assumption. At individual level, you know, if I plan the consumption of Tth period, that will be done on the basis of my income of the previous period, isn't it?
Yes, ma'am.
If yesterday somebody gives you, you know, 100 rupees, then you will plan, today I'll buy an ice cream, isn't it?
Got it.
Is it right or not?
Thank you very much.
Ice cream, you will like to buy something using that 100 rupees. Is it okay? So
Yes.
in previous period, you should have money in your hand, and then you will plan how we will spend that money. And in the next day, on the next day, or in the Tth period, you will spend accordingly, consume accordingly. Okay. So first money comes in your hand and then you plan for the consumption. So at individual level, this happens also if you consider the economy as a whole, you know, the consumption expenditure, the aggregate consumption expenditure will follow this kind of principle. Whatever income the economy earned in the last period, on the basis of that, the economy will decide what will be the consumption expenditure. So this is the assumption of the Samuelson's model. Okay. However, this assumption is not a very stringent assumption. It is a very consistent assumption. This happens on regular basis. So is it understandable?
Yes, ma'am, it is understandable.
Any other question? Anyone up to this?
Ma'am, can you explain that question once? Why beta lies between 0 and 1?
Do you know what is MPC, marginal propensity to consume?
Yes, ma'am.
So what is marginal propensity to consume? Change in consumption due to change in income?
Yes, ma'am.
In general, we write the consumption equation as in a macro context. In general, we write the equation in this way. Everybody?
Yes, ma'am.
So what is the meaning of beta then?
Marginal propensity to consume.
As MPC, so it is P by P
The
bar.
slope.
This one? Okay. So it may happen that your income is changing, however, your consumption remains unchanged. Is it possible? dy,
Yes,
Yes,
ma'am.
ma'am.
however, dc is 0. Is it possible?
Yes, ma'am.
Okay. So the minimum possible theoretical value for beta is what?
0.
Okay. And is it possible that your change in consumption is exactly equal to your change in income? DC is exactly equal to dy?
Yes, ma'am. Okay, ma'am, I got it.
Okay. So the maximum change in consumption is equivalent to maximum change in income. Okay. However, generally what we find that dc by dy is not 0 and generally it is not even equal to 1. So we follow the strict inequality. So beta lies in between 0 and 1. So this idea is beta lies between 0 and 1. This idea is coming from the basic national income identity or from the idea of consumption expenditure, from the idea of MPC, marginal propensity to consume. Is it now clear?
Yes, ma'am.
Related to this model only. You know, somebody asked truly why I am using the calculus, you know. This concept is not related to this particular problem. It's not the problem related to the difference or differential equation, you know, or it is not related to the dynamic framework. It is relevant equivalently for the static framework too. This is the basic idea of marginal propensity to consume. That's all. Okay, should I proceed? Every point is clear to all of you?
Yes, ma'am.
In this slide?
Yes, ma'am.
Yes, ma'am.
Next step. So we have solved up to pi. So pi value is there in our hand. Now we have to move towards complementary function. Here, the calculation is bit complicated compared to the first order difference equation. As you know, as we will go for the higher order, naturally there will be bit complication in the analysis or in the steps. However, it's not difficult. So please concentrate on the slides. I hope all of you will understand the matter. Now, first what I'm doing, what I am considering, I'm considering the deviation of present value of income from the equilibrium values. Okay. So I'm subtracting equation 6 from equation 5. So what is equation number 6? Everything in terms of YE. And equation 5, the same equation in terms of YT minus 1, YT minus 2. So I'll consider YT minus YE, YT minus 1 minus YE, YT minus 2 minus YE. So the deviation form we will consider. We will subtract 6 from 5. So we are getting YT minus YE is equal to beta into 1 plus alpha, YT minus 1 minus YE, L minus alpha beta, YT minus 2 minus YE, G naught minus G naught is cancelling. Is this equation okay? Subtract equation 6 from equation 5. This is equation number 5. And this is equation number 6. Subtract 6 from 5. I'm using
Ma'am, the subtraction of the present value.
I didn't just repeat your question.
You said the subtraction for deviation of present value. Then you said something and missed that.
All the values, YT minus YE. In the left hand side, the value is for the Tth period. In the right hand side, the values are there for T minus 1th and T minus 2th period. Okay, so all the values present in equation number 5, from those values, I am subtracting the equilibrium value YE, and equilibrium is intertemporal equilibrium. So for T minus 2th period, YE is the equilibrium, T minus 1th period, YE is the equilibrium, Tth period, YE is the equilibrium. Okay?
Yes, ma'am.
Now, I'm doing a hat operation. Hat operation. All the deviation from equilibrium will be presented using hat. So, YT minus YE is called YT hat. YT minus 1 minus YE is called YT minus 1 hat. YT minus 2 minus YE is called YT minus 2 hat. So I am doing hat operation to present the model. Okay. So I hope all of you got equation number 8. Next. Let YT hat is equal to B to the power T. YT hat is equal to B to the power T, where B is any arbitrary constant. This is not a trial solution as such. Actually, we need to write a quadratic format in case of second order difference equation. In other words, we need to write the characteristic equation in case of second order difference equation. And to find the characteristic equation, we set YT hat is equal to B to the power T, where B is any arbitrary constant. So all yt hat, yt minus 1 hat, yt minus 2 hat will be replaced by corresponding b to the power t, b to the power t minus 1 and b to the power t minus 2. And we are getting equation number 9. Without losing any generality, we may set t is equal to 2. Why I am setting t is equal to 2, not 1, etc.? Because if I set t is equal to 2, the minimum value will be 0. T minus 2 will be 0. Otherwise, if I consider t to be equal to 1, in that case, this will be b to the power 0. However, this will be b to the power minus 1. So there will be operational complications. For that matter, we are setting t is equal to 2. If it is a third order difference equation, we have to consider t to be equal to 3. Fourth order difference equation, in that case, for a similar construct, we will consider t is equal to 4. Okay? So that the minimum possible value of time becomes 0. So without losing any generality, we may set t is equal to 2 in equation number 9. Hence, we get a quadratic b square minus beta into 1 plus alpha. This I am putting in the left hand side. Entire thing I am putting in the left hand side. So minus beta into 1 plus alpha into b, since t is equal to 2, plus alpha beta, b to the power 0 is equal to 1. This is equation number 10, and this is a quadratic equation of b, which is called the characteristic equation of 9. Please check everything. If you have any doubt, any question, please ask me. So everybody has concept about characteristic equation, characteristic roots from the class 2 level mathematics. Am I right?
No, ma'am.
No, ma'am.
Characteristic roots you don't know?
No, ma'am.
No, we know quadratic roots, not characteristic roots.
Okay, these are characteristic roots too. Minus b plus minus root over b square minus 4ac by 2a. That you know?
Yes, ma'am. Yes, ma'am.
Okay, so these are all characteristic roots too.
Okay, ma'am.
Okay. So equation number 10 is okay to all of you? Anyone, any question? Up to equation number 10, the quadratic? Okay. Equation 10 has two roots, b1 and b2 say. Okay, this we call the characteristic roots. You know, you call it quadratic roots. You know, the actual name is characteristic roots. The characteristic roots are b1, b2, and these are given by minus b plus minus root over b square minus 4ac by 2a. So this is the equation 10. Please write down the values of the roots b1 and b2 looking at this equation, and then I'll move to the next slide. First, minus b. That means minus of beta into 1 plus alpha. That means simply beta into 1 plus alpha. Everybody?
Yes, ma'am.
Beta into 1 plus alpha. Because it is minus b. This b is not this b. Okay, I'm just following the Sridharacharya principle, you know. Do you know this is the Sridharacharya principle?
Yes, ma'am.
Yes,
Yes,
ma'am.
ma'am.
Okay, so minus b is beta into 1 plus alpha plus minus root over b square minus 4ac. So what is b square? Beta square into 1 plus alpha whole square minus 4ac. What is the value of a?
Uh,
1.
1. Very good. And what is the value of c?
alpha beta.
Alpha b. Okay. So minus b, that means beta into 1 plus alpha plus minus root over beta square into 1 plus alpha square minus 4 alpha beta. This is the numerator. And what will be the denominator?
2.
2.
2.
So this is the point. B1, B2, these are equal to beta into 1 plus alpha plus minus root over beta square into 1 plus alpha square minus 4 alpha beta divided by 2. So this can be presented as beta into 1 plus alpha by 2 plus minus root over beta square 1 plus alpha whole square minus 4 alpha beta by 2. Any question up to this? Any question up to this?
No, ma'am.
Okay.
Ma'am, why are we not putting any restriction on the square root part here?
From the beginning, why we will put the square roots? You know, the roots may be imaginary. Then you can have a kind of solution. The roots may be real. Then you will get another kind of solution, isn't it?
Okay, ma'am. Okay, ma'am.
Okay, so we will use all the concepts. We will not restrict the analysis for a typical setup. We will consider all possibilities, okay? Roots may be real, roots may be complex. So we will consider all possibilities. So we will keep the things as it is. Now from equation number 11, the sum of the roots b1 plus b2. What is the value of sum of the roots for any quadratic like this? What is b1 plus b2 and what is b1
minus b by
b2?
a.
Minus b by a.
Minus b by a.
b1 plus b2 is equal to minus b by a. So here what will be the value then?
Alpha beta.
Beta into 1 plus alpha.
Beta into 1 plus.
Beta into 1 plus alpha. Why alpha beta?
Because okay, yes, ma'am. Minus b by a. Yes, ma'am. Yes, ma'am.
Minus b by a. So this is b. So beta into 1 plus alpha, a is 1. So simply this one. And what is b1 into b2?
C by a.
C by a.
So what will be the value?
Alpha beta.
Alpha into beta.
Alpha into beta. Okay. So b1 plus b2 is minus b by a. So beta into 1 plus alpha by 1. So it is beta into 1 plus alpha. Whereas b1 into b2 is equal to c by a, which is alpha beta. So everybody got this point? Any doubt? Any question? Any clarification? Next. 1 minus b1 into 1 minus b2. Okay, 1 minus b1 into 1 minus b2. That value also we are calculating. So if you put the things, it is 1 minus b1 minus b2 plus b1 b2. So it is 1 minus b1 plus b2 plus b1 into b2. So if I put the value b1 plus b2 and b1 into b2, we are getting simply 1 minus beta. So please check the values. If there is any doubt, any question, please ask me. So can you tell me whether 1 minus b1 into 1 minus b2 will be positive or not?
Positive.
Little positive.
Positive. If beta strictly lies in between 0 and 1, it will be positive. And if beta is 0, it will be equal to 1. And if beta is, if you allow weak inequality, beta is 1, it will be 0. Okay. For the standard practice, it is positive. Okay. So if you follow the norm of MPC, marginal propensity to consume, so can we write this lies in between 0 and 1? Everybody?
Yes, ma'am.
Yes, ma'am.
Since beta lies in between 0 and 1, this product also lies in between 0 and 1, and I am calling it equation number 11A. Okay, so this we are keeping in between. So we have pi in our hand, and on the basis of the second order difference equation, first we derived the characteristic equation, and for that characteristic equation we have calculated two roots, and then using the properties of the characteristic roots we derived equation 11A. Next, we will try to address the convergence, divergence, all this kind of issues, stability issue, in fact. And we will move towards calculation of complementary function, CF. Okay? So all these things we are going to do. Let's now address the question of convergence. When B1 and B2 are real and distinct, when B1 and B2 are real and distinct, B1 into B2 is equal to alpha beta greater than 0. Is it okay to all of you? B1 into B2 is equal to alpha beta, that you know. Now I am considering the fact that B1 and B2 are real. So what is the difference between the real roots and complex roots? Anyone?
Complex roots have an irrational number.
বলো যে বলছো।
Ma'am, complex root there is an irrational number. ওখানে যেখানে b square minus 4ac is negative. So like b square is greater than 4ac.
B square is greater than 4ac, yes. So the element which is there inside the root, that will be negative there. That is 4 alpha beta will be greater than beta square into 1 plus alpha square. Whereas
Yes,
real, what will happen?
Ma'am, in real, beta square into 1 plus alpha square is greater than minus 4 alpha beta.
Is greater than 4 alpha beta, not minus.
Or equal to.
Yeah, 4 alpha beta, yes, ma'am.
Or equal, yes. So when B1 and B2 are real and distinct, B1 into B2, that means this term, this term, B1 into B2, which is equal to alpha beta, that is greater than 0. When both the roots are real, then their product is greater than 0. Their product in this case is alpha into beta. Therefore, it is greater than 0. This implies B1 and B2 possess the same algebraic sign. Moreover, because if both are negative, in that case also it will be positive. If both are positive, in that case also it will be positive. The product will be positive. So B1 into B2, which is equal to alpha beta greater than 0. If the roots are real and distinct, their product is positive. So in that case, alpha into beta is positive here. This implies B1 and B2 possess the same algebraic sign. Moreover, B1 plus B2, which is beta into 1 plus alpha, that is also positive when the roots are real and distinct. This implies B1 and B2 are each positive. Okay. Now, look at this expression. It is beta plus alpha beta. Beta plus alpha beta. Alpha beta is positive. Alpha into beta, that is positive, because if the roots are real and distinct, their product will be positive. So, alpha into beta is positive. Now, if the sum of the roots also is positive, you know, in that case, beta is a number lying in between 0 and 1. Okay, so if the entire term you want to be positive, in that case, both B1 and B2, both the roots will be positive, isn't it? B1 plus B2 is equal to beta plus alpha beta. Individually, beta and alpha beta, both the terms are positive. So,
Yes, ma'am.
both the roots are, in that case, positive. So, the solution to 9 in two constants. So, we are keeping all these things in our mind. B1 into B2, which is alpha beta, that is positive. B1 plus B2, that is also positive. And 1 minus B1 into 1 minus B2, that lies in between 0 and 1. The solution to 9 in two constants to be determined from initial condition. In fact, we are going to calculate the CF part. The solution to 9 in two constants to be determined from initial condition is given by yt hat. Here, instead of considering yt is equal to a b1 to the power t plus b b2 to the power t, we consider the deviation, that is yt minus ye, that is equal to a b1 to the power t plus b b2 to the power t, where b1 and b2 are two characteristic roots of the second order difference equation in yt. Yt hat is equal to yt minus ye, so yt is equal to a b1 to the power t plus b b2 to the power t plus ye. So look, now you are getting the shape. The time path is equal to the CF part plus PI part. In case of first order difference equation, separately we found PT is equal to AB to the power T kind of matter. And then we added the PI part. Now here, if I consider the hat operation, that is if I consider the deviation form, and we set yt hat is equal to ab1 to the power t plus b b2 to the power t, in that case, we are getting yt is equal to ab1 to the power t plus b b2 to the power t plus ye. So we are getting the shape of the time path. Now, if yt,
Explain this portion once more. This yt hat equal to a b1 to the power t.
we have to determine the time path of y. Okay. And from the basic idea of difference equation, you know, to derive the time path of any variable, you need two components, the complementary function component and the particular integral component. Am I right?
Yes, ma'am.
Already particular integral component is in your hand, which is g naught by 1 minus beta. G naught by 1 minus beta. So we are moving towards the calculation of CF and thereby calculation of the entire time path of y. Now here in between, we have considered hat operation. Hat indicates the difference between one time value from the equilibrium value. Okay, so this equation 8 is there, which is based on the hat operation. So while we are trying to find out the complementary function, we are defining complementary function for yt hat. Not for yt, but for yt hat. And if you look at the complement, this is the second order difference equation and you have two roots. So the complementary function you have to define will consist of both the roots. So it is defined as ab1 to the power t plus b2 to the power t, where a and b are two arbitrary constants which should be determined from the initial condition. Okay.
Yes, ma'am. Thank you so much.
Yt hat is equal to yt minus ye. So this complementary function itself can be written as yt is equal to ab1 to the power t plus b2 to the power t plus ye. Is this equation all right? Is this equation is all right to all of you?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
So this equation itself is generating the time path isn't it? We do not separately require to add pi. It is keeping yt here and this is CF part and already pi part is there. So this equation itself is generating the equation for the time path. Isn't it? We have to find the value of B1, B2, A, B. We have to put these matters. However, the construct itself is giving the idea of the time path. Is it acceptable?
Yes, ma'am.
So if it is acceptable that the shape of the time path will be like this, where we have to put the values of capital A, small b1, capital B, small b2, etc. We can give the idea of convergence from this very equation only. If yt tends to ye, because already the values of b1, b2, these things are there. We know these values. What is the value of b1? What is the value of b2? b1 is beta into 1 plus alpha by 2 plus this value. b2 is the same thing minus this value. So we have idea what are the values of b1, b2. A and B we need to calculate from the initial condition. However, we know the values of b1 and b2. So if yt tends to ye as t tends to infinity, the time path of income will be stable. Now, given this shape of the equation, the time path of income will be stable. That is, yt will move towards ye as t tends to infinity. If this first part, ab1 to the power t plus b2 to the power t, tends towards 0 as t tends to infinity, yt tends to ye as t tends to infinity if and only if ab1 to the power t plus b2 to the power t, this entire amount tends towards 0 as t tends to infinity. Is it right? Understandable?
Yes, ma'am.
If I want that sorry. We need that. This implies everybody?
Yes, ma'am.
So we need this. Okay. Now this is possible if and only if mod B1 less than 1, mod B2 less than 1, mod B1 less than 1, mod B2 less than 1. Is it acceptable?
Yes, ma'am.
This also satisfies the specification in 11a. So look at 11a. The specification is 1 minus b1 into 1 minus b2 should lie in between 0 and 1. So mod b1 less than 1, mod b2 less than 1. This satisfies the nature of the characteristic roots in this framework too. One of the natures of the characteristic roots is 1 minus b1 into 1 minus b2 will lie in between 0 and 1. Now, if mod b1 less than 1, mod b2 less than 1, this is satisfying this characteristic of, or this nature of the characteristic roots which we have considered in this framework. Are you understanding what I am trying to tell you? If you have any question, please ask me. If I need to repeat, please tell me. It's fine to all of you?
Yes, ma'am.
Yes,
Yes,
ma'am.
ma'am.
If I change the position, yes. Just a minute, this is not working. Okay. To ascertain the nature of the time path of income, we consider the discriminant of the quadratic equation. Okay, discriminant means the matter which we have inside the root value. To ascertain the nature of the time path of income, we consider the discriminant of the quadratic equation 10. Discriminant of the quadratic equation 10. Now, what is discriminant? A matter which we have inside the root. You know all these things?
Yes, ma'am.
So it is delta is equal to, capital delta is equal to beta square into 1 plus alpha square minus 4 alpha beta. The roots are real if beta square into 1 plus alpha square minus 4 alpha beta is greater than equal to 0, which in turn implies beta is greater than equal to 4 alpha by 1 plus alpha square. Is this fine to you? 1 beta will be cancelled, you know. It is beta square into 1 plus alpha square greater than equal to 4 alpha beta. So I'm cancelling 1 beta. So it is beta greater than equal to 4 alpha by 1 plus alpha whole square. Is it okay? The roots are really beta greater than equal to 4 alpha by 1 plus alpha square. Is it fine?
Yes, ma'am.
Yes, ma'am.
Also, I'm adding the point, if roots are real, the time path will be monotonic. On the other hand, roots are complex conjugates if beta less than 4 alpha by 1 plus alpha whole square. If the roots are complex conjugates, the time path will be oscillatory. So for the second order difference equation, remember, if roots are real, the time path will be monotonic. If roots are imaginary or complex conjugates, in that case, the time path will be oscillatory in nature. Okay, so slowly we are moving towards the time path, nature of the time path of income. We know if mod B1 and mod B2 are less than 1, time path will be stable, convergent. Now I am adding if beta greater than equal to 4 alpha by 1 plus alpha whole square. In that case, the time path will be monotonic. Otherwise, the time path will be oscillatory.
Ma'am, I have a question.
Yes.
Ma'am, for the monotonic and oscillatory part, why did we have to consider the determinants? Why couldn't we just do it on depending on whether B is positive or negative in yt equals to a bt plus
Because here
a.
you have two roots. You know, you have two roots.
Yes, ma'am. Yes, ma'am.
You have two roots. Okay, so you have to consider nature of both the roots at a time, you know. So B1 greater than 0, B2 less than 0, B1, all these things are not possible because you need to satisfy all these conditions too. And already we found that B1 into B2 alpha beta greater than 0, B1 plus B2, that is also greater than 0, and from there actually we have derived the stability condition. Okay, so simultaneously we have to understand the nature of the roots, you know, nature of both the roots. Here we will be not able to consider one is positive, one is negative. When we are getting the quadratic, the nature of the roots can be understood using the idea of whether the roots are real or whether the roots are complex conjugates. As long as you consider the first order difference equation, in that case, B, which is also the root of the, you know, the time path, this B value you can consider as positive, negative. However, when you are considering the quadratic, in that case, the nature of the roots will be analyzed using the notion of whether the roots are real or whether the roots are complex conjugates. Positive, negative, this idea, this notion will not work in context of a quadratic framework.
Yes, ma'am. Thank you.
Okay, so now we have to combine all these things. Small b1 less than 1, small b2 less than 1, you know, with that beta greater than equal to 4 alpha by 1 plus alpha whole square, beta less than 4 alpha by 1 plus alpha whole square, you know. So we have to combine all these possibilities to understand the actual nature of the time path, whether we will get monotonic convergent time path, monotonic divergent time path, oscillatory time path in case of oscillation, whether the time path is uniform oscillatory, whether the time path is explosive oscillatory, whether the time path is damped oscillatory. All these things we need to understand one by one, combining the stability condition as well as whether the roots are real, whether the roots are complex conjugates, you know, combining these two, we need to understand the matter. Okay, so up to this, tell me whether you have any question, you are understanding the matter, or I need to repeat anything. You know, this part and this part. Take this part. And then also check that part. Is it clear to all of you?
Yes, ma'am. Ma'am, why monotonic and why oscillatory? How we will verify?
Okay, so this will depend on the nature of the roots. These you don't need to verify. You need to check whether the roots are real. If the roots are real, in that case, you know, your time path will be monotonic in nature. If roots are complex conjugates, in that case, your time path will be oscillatory in nature. Okay, so one more thing here, it will be better to add. Just after this, okay, this also satisfies the specification given in 11A. So before coming to this part, please add since B1 and B2 are greater than 0, B1 and B2 are greater than 0. Just let me use the we got the condition as each positive okay. So please add this part. So the required stability condition in the Samuelson's framework is given by alpha beta less than 1 or beta less than 1 by alpha. I mentioned it in terms of mod B1 less than 1, mod B2 less than 1. And then we can clarify, the condition in terms of the parameters of the model. Since both B1 and B2 are positive, B1 into B2, which is equal to alpha beta, that is less than 1. And this gives the condition beta less than 1 by alpha. So this is the required condition of stability in the Samuelson's framework. So these few sentences you should add before coming to roots are real, roots are complex conjugates, etc. Okay? This condition is clear to all of you. The stability condition in terms of accelerator and multiplier, beta should be less than 1 upon alpha, or alpha into beta less than 1. This is the required condition of stability here. And then you are understanding in terms of alpha and beta when you will have the monotonic time path and when you will have the oscillatory time path. So once you understand up to this, you need to plot two curves in the alpha beta plane. One curve will be alpha into beta is equal to 1. Another curve will be beta equal to 4 alpha by 1 plus alpha whole square. Okay? I'll not do this part today. I'll do it in the next class, I think tomorrow. However, actually what we have to do, I have to consider the alpha beta plane. I need to draw the line alpha beta is equal to 1, which is a rectangular hyperbola. And we need to draw the curve beta is equal to 4 alpha by 1 plus alpha whole square, which is a parabola. Okay, so we need to draw these two lines, and then we need to define the zones where alpha into beta less than 1, alpha into beta greater than 1, beta less than 4 alpha by 1 plus alpha whole square, beta greater than 4 alpha by 1 plus alpha whole square. So combining all these things, we will finally derive the different types of time path here. Different types of time path here. So that I'll do tomorrow. Tomorrow morning I'll do that. Before that, you look at how to solve a second order difference equation. Take all these things, how we are defining characteristic equation, characteristic roots, how we are writing the properties of the roots. From the properties of the roots, how we are stating the stability condition, and how we are defining whether the time path will be monotonic or time path will be oscillatory. So please look at all these things, and I'll continue tomorrow.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.
I'll take the attendance, okay? Z8 sir will talk to you. I think one group has presentation or whatever. Just Upanita, would you tell me who are absent?
Yes, ma'am, just a second. Orgo,
What's happened to Orgo? What is his roll number?
1 second, I'll just find it.
Okay, first I'm giving P and to everyone, and then I'll check. Only Orgo is absent. I think some other people are also absent.
Yes,
Arpan
ma'am.
also.
Arpan is absent.
Arpan is absent today. What is the roll number of Orgo? Aryan is there?
Yes, ma'am, present.
Okay. So anyone else is absent?
Ma'am, keep also.
People are absent because there is 39 people.
Richik is
Chris is
absent.
not there